Now here we discuss programmable interrupt controller. This IC number is 8259. Now in 8085, if you take this is the 8085 microprocessor. Now in this total 5 hardware interrupts are there. One is trap. The first high is having the highest priority trap. RST 7.5, RST 6.5, and RST 5.5. Now these are the vector interrupts. When the interrupt is occurred, microprocessor knows that where it has to jump and it will execute the ISR. Now coming to the last interrupt, that is INTR, fifth interrupt INTR. This is the non-vector interrupt. Now for that microprocessor doesn't know where it has to jump. So now for that what? To handle these interrupt, now for this, we are connecting the 8259 IC to this 8085. 8259 IC. This is a programmable interrupt controller. Now, this 8259 can control the 8 interrupt. Now, IR0 to IR7. Total, it will handle the total 8 interrupts. Now, by connecting this IC to the 8085, so interrupt handling capability of this processor can be increased. So now by using the single pick IC, so the maximum number of interrupts are what? Increased to 8. Now again, by connecting such ICs in cascade means what? Now this pin, now here I am connecting the one more 8259 IC to the INT. Now for this interrupt request is connected to the INT of 8259. Again, it is having the total IR0 to IR7, 8 interrupts. Like that, for 7 interrupts signals, so for 8 interrupt signals, 8259s are connected. Thereby what? Now each IC is handling the 8 interrupts. Now such ICs are how many total? 8 ICs are connected in cascade to the first IC. Thereby what? The total number of interrupts are increased up to 64 levels. So this is about the 8259. By connecting the first one single pick IC, the interrupts handling capability is increased up to 8. Now for this 8, if we are connecting the 8 more ICs in cascade, so 8259 are connected, 8 ICs are connected to the single IC. So thereby what? The total number of interrupts handling capability of the interrupts is increased up to 64 levels. Now which IC is connected directly to the microprocessor is called the master, and the remaining all ICs are called the slave ICs. So now this is about the programmable interrupt controller. Why we have to connect this IC to the microprocessor means what? To increase the interrupt handling capability. Now here we will see the features. Now this Intel 8259 is designed for both 8085 and also 8086. In 8086 total 2 hardware interrupts are there. So that also increased up to 64 levels, and it can be programmed either in level triggered or in the edge triggered, and interrupts can also be masked by using this 8259. So this is about the features. Now we will see the block diagram of 8259. Inside the 8259, these are the blocks it is having. Now coming to the data bus buffer. Now this data bus buffer is acting like a mediator between the input 8085, and now this bus is connected to the 8085. Now here 8085 is connected to this data bus is connected to the 8259. So this block is acting like a mediator between the 8259 and 8085 microprocessor. Now it takes the control word from the 8085, and this control word is stored into this control logic register. Inside the control logic register, control register is there. In this register, the control word is loaded. Now for that what? Processor will send the control word through this bus to the data bus buffer, and after that the control word is loaded into the control register which is inside the control logic. And also microprocessor will read the status of the three registers. Now here you can see interrupt service register, interrupt request register, and interrupt mask register. So these register status also microprocessor read by using the now this status will be placed in the data bus buffer, and after that it is kept on the data bus. So thereby what processor will read the status of the three registers. And also now here we have seen that these are the vectored interrupts, and microprocessor knows the vector address after receiving the interrupts. Now coming to the INTR. So microprocessor doesn't know the vector address. So thereby after receiving the interrupt from this pick, now if any one of the interrupt request is generated, then this here INT pin is there that is connected to the INTR. So it will send the interrupt request to the 8085 to this INTR pin. In response to that, it will send the INTA, and what for? Now to know the vector address and to to execute the ISR, to service ISR. Now microprocessor need the address, so for that it will send the INTA. In response to the INTA, 8259 will now here after receiving the INTA, call and address. Now what for the call instruction, you know that once the call and address is given means what, processor will jump to this particular address and it will execute the program over there, and again it will come back to the main program. So after sending the INTA, this pick this programmable interrupt controller will send the now call instruction opcode. Now this call and address means what it is having. For call instruction opcode is there. Now whatever the address is specified over here, lower order address, and after that higher order address. So first microprocessor will send the opcode in response to this INTA. It will send the opcode through the data bus. Now through this data bus, it will send the opcode first. Again the microprocessor will send the acknowledgement signal to the pick. Again INTA will be sent to the 8259. Thereby it will send the again lower order address to the 8085. Again it will send the acknowledgement signal to the 8259. Again the 8259 will send the higher order. Now here three times. The first one is what? It will send the opcode. INTA, after receiving the INTA, it will send the opcode. Again, INTA will be received by the 8085. Again, it will send the lower order. And after sending the lower order address, it will send again INTA. Thereby, what it is sending the higher order address. So, three times 8085 microprocessor will send the acknowledgement signal to the 8259. For sending the opcode, for sending the lower order address and higher order address, again, this data bus buffer and this data bus is used. So through this data bus, it will send the, now here the data bus length is what, 8-bit data bus is connected to this data bus buffer. Now by using this data bus, it will send the opcode, lower order address and higher order address. Not only that, it will send the status register information, and the processor will send the control word through this bus. Now this is about the data bus and data bus buffer. Now coming to the read write logic. If you see here, the control the signals are read write signals. Now read signal is there, write signal is there. A not a single address bits. Now in 8085, so 16 address bits are there. A not to A15, total 16 address bits are there. So this A naught bit is connected to the A naught bit of 8259, and here in 8085 read signal is there, write signal is there. This read is connected to the read and write is connected to the write of the 8259, and chip select bit is there. Now, if the chip select bit is equal to 0, then only this 8259 can read and write the data. Now, this read operation is used to read the status of these three registers, and write operation is used to load the or write the control word into the control register, which is in the control logic. And this A naught bit is used to now Here, how many number of address lines are used means how many number of registers are there to read and write. If only one address bit is used means what? By keeping a naught bit is equal to 0 and 1. So by giving the write command, so two registers can be used. By keeping 0, one register can be used to write, and by keeping 1, another register can be used to write. So in a control logic, two control registers are there. One is for the initialization and another one is for the operation purpose. So that's why, so two different registers are there to select that this A naught bit is used. Now coming to the cascade buffer comparator. Now here three cascade pins are used. Now already we have seen that, so total 8259 ICs can be connected in cascading to this 8259. So now which slave register is, slave IC is being executed by the 8259, that can be indicated by these cascade bits. Now here total 8 slave ICs can be connected. Now which slave IC is being served by this 8085, that is indicated by these cascade bits. Now here if it is 000 means what? So the first one, the first IC which is connected to the IR naught, this IC is being served by the 8085. Like that, so total 8 bits are there. Now here 3 pins are there, so 2 to the power of 3 is equal to 8. So which IC is being served, so can be indicated by these 3 pins. Now coming to the SP oblique EN, which indicates the, so now this IC is operated in the slave mode or master mode. This pin will indicate. Now before going to operate, here two modes are there. One is a buffered mode, another one is a non-buffered mode. Non-buffered mode means what? So in the non-buffered mode, this pin is used to indicate whether it is operated in the slave mode or master mode. In the buffered mode, this pin is used to enable the data buffers. Now coming to the control logic. Now this control logic is the center of the PIC and controls the functioning of every block, and it has the INT. Now it is generating the INT. Now when the interrupt request signals are generated, then here it is having the INT and INTA. This INT is connected to the INTR of the 8085, and INTA of 8085 is connected to the INTA of 8259. And how this will be generated later I will explain. This is about the control logic. Now coming to the interrupt request register. Now here this is the 8-bit register which is having the IR0 to IR7, total 8 bits are there. Now for this water, now here 8 pins are connected over here and 8 devices can be connected to these pins. Now these 8 devices can generate the interrupt request. Now which device is requesting the interrupt signal, that pin will be, that bit will be set to 1. Now for example, the device which is connected to the IR not is generated the interrupt signal, then that particular bit in this register will be set to 1. Like that, this IRR will indicate the interrupt request signals. Now coming to the ISR. Now ISR is nothing but interrupt service register, which stores the interrupt level which is currently being executed by the 8085. So now coming to the interrupt mask register. Now this is also 8-bit register. So which interrupt is being served, that bit will be set here. Now again coming to the interrupt mask register. Now which is also 8-bit register, which is having the IR0 to IR7. So which interrupt should be masked, that bit will be set here in this. So that data is stored in this register. According to the data, so the particular interrupt will be masked. Now if this particular bit is set to 1 means what? That particular interrupt should be masked. If it is 0 means what? So that is, however it is not going to do anything with that. Now if I wanted to mask the interrupt to 1, so now if I'm setting like this means what? Whenever the interrupt IR not is generated, so this register will, now this bit will be masked, that register means masking means what? that will be ignored by the 8259. That interrupt request is not served by the 8085. So like this, if any interrupts are generated, if that should not be considered means what? So particular bits supposed to be set here. By setting the mask bits, so that particular interrupt will be ignored. Now coming to the priority resolver. Now this priority resolver will check the ISR register, IRR register and IMR register, and it will set the priority of the uh, priorities of the interrupts. And according to the priority of the interrupts, now interrupt with the high priority is set into the ISR, and whichever the interrupt is set in the ISR, that is reset in the IRR. Now immediately that pin will be reset in the IRR. Now this is about the priority resolver. After selecting the interrupt, so that interrupt signal is given to the INTR. Now this is about the block diagram. Now what are the events occurred now in this 8259 means what? Now after connecting the devices to these interrupt, if more than one devices are sending the interrupt request, so those bits will be set in this register. So according to that, now if any any requests are should be masked, then here the data should be loaded. Now depending upon the request signal, so priority resolver will set the priority to these interrupt request, and it will set the highest priority interrupt into this interrupt service register, and immediately that signal will be reset here. Now whenever the interrupts are generated through this INT, so it will send the interrupt request to the 8085. So in response to that, it will send the acknowledgement signal to the INTA. So after receiving the acknowledgement signal, so that highest priority signal will be set in the now which interrupt should be served. That interrupt bit will be set here. Accordingly, uh, now, after receiving the INTA, this 8259 will send the opcode of call to the 8085, and after that it will send the acknowledgement signal, and it will send the lower order address, and after that again it will send the acknowledgement signal, and after that again it will send the higher order address. Thereby microprocessor knows the address where it has to jump, and means what? It is sending the vector address to the 8085. So after that, microprocessor will jump to that particular address. Now call address is given means what? Processor will jump to this address, and whatever the program is written over here, it will execute. Again, it will come back to the main program. So this is about the events happening inside the microprocessor. So in the programmable interrupt controller. Now like this programmable interrupt controller is handling the interrupts.